Week 6, lesson 1. Okay, so I'm going to draw a normal curve the way you've seen these before, or at least I hope you have seen these before in Algebra 2. Normal curve where the high point is represented by the mean, and it's counted out on both sides by standard deviations, which are represented by the letter sigma. Okay, so this is what's called the normal. The symbol for it is a capital X. Sometimes you'll see it with these little bars kind of on the tops and bottoms of the X's. And then as far as the notation that you'll see on papers and in exams, you'll see that X with a little tilde, and then N to represent that it is a normal curve. And in the parentheses, you'll see a couple of numbers. And the order of those numbers, the first one is the mean, and the second one is the variance. I'm sorry, I can't fit that very well. All right, but the point of this lesson is there's a way to standardize this, okay? So we're gonna draw another curve called the standard normal. The curve itself looks the same. The difference is, instead of having some random number being the mean, we're gonna standardize it so that the mean is 0. And instead of counting out by sigmas, we're gonna count out by ones. So the symbol here is different, it's a Z. Over here, we're going to call this Z. And instead, like I said before, instead of it being some random number for mean, it's going to be a 0. And the variance and the standard deviation are both going to be a 1. Now, the great thing about this lesson is it's done in your calculator. So in the box up here at the top is sort of the keystrokes. And I'm going to show you how to do this actually on the calculator. Okay, so we're going to try the very first example. And if you're looking at your paper, you can see that there's some buttons to push, which is second, which is the blue button, VARS, which is right here, and then we want the normal CDF, which is option number 2. Again, you can either use the up and down arrows, or you can just hit the number 2. Okay, so now on the screen, it's asking you what is the lower and what is the upper. So I'm looking at this picture and I see that to the left, it just goes on and on and on and on forever. So this number is an extraordinarily large number that is to the left. It's like negative a cajillion, all right, which is fine. That's what we want. The upper number has to be the 0.82 that you're seeing underneath the bottom. All right, because this is standardized, right? Again, it says in the directions, it's a standard normal distribution. So that means that the mean is 0. I can leave that one. And the standard deviation is 1. And then you hit paste. Okay, you're going to have to hit enter a couple times. All right, in fact, if you look down here, you can see that I had to enter 5 times. But this is the area. It's 0.79389, etc. The directions say round to 4 significant digits. I'll let you do that. Okay, so I'm now on B, which is going to be approached the exact same way. So second VARS 2, the left end, right, the lower limit is a very large negative number. The upper is at 1.24. Okay, and then the other values are not changing. So I can repeatedly hit enter until it gives me the answer that I'm looking for of 0.8925. Okay, now the next one, I'm looking at C, and you can see that the shading it's facing the other direction. So when I go over here to normal CDF, the lower limit is the number that I'm plugging in. This is where I'm plugging in the negative 1.2, excuse me, not 2, 49. All right, and the upper is going to be some very, very, very large number, okay? It doesn't matter what number you plug. It just needs to be really, really, very, very large. These values are not changing. So when I hit enter and enter again, I get my probability, right? I get the shaded value, which is 0.9139 to 4 significant digits. Okay, now on D, these are actually the ones I like the best. And the reason I like these the best is I can very easily see the lower limit of negative 0.92. And I can also easily see the upper limit of 2.03. The mean, standard deviation don't change, and you get a probability here to 4 significant digits of 0.80000. And then for part E, again, approach the exact same way. Since you know the lower is 0.67, and you know the upper is 1.59. When you hit enter all these times, you will get that probability. So there's the answers filled in. Okay, so keep in mind, the way we did these problems was we know what the number is below, right? For example, here, we know this number and we're trying to find the area, or sometimes it'll say find the probability. Okay, so we're trying to find this amount. Because on the next page, you'll be given the area, right? So you can see, for example, on A, I know what the area of this whole shaded part is. I'm trying to figure out what this letter A is. Okay, and again, this part's also going to be done on the calculator. Okay, so now I'm on the next example where this time you're given the area and you're trying to find out what the value of A is underneath. Okay, so it's a different button. It's in the same menu. I still have to hit second bars, but instead of hitting option 2, I'm going to hit option 3. Inverse norm is going to help you find the number underneath. So it's asking, right? It's asking you some questions. All right, so the area that it's indicated is 0.87. Okay, this is a standard normal distribution. So the mean and the standard deviation are going to be the same. Now this is asking which way is the tail pointing, right? So like in this one, if you look at A, you can see that the long skinny part is pointed to the left. So you just hit enter. Okay, maybe not, maybe hit under. There we go, hit the lower. Now I can hit enter for paste, and it will tell me that the A value right there, the A value is that number. Okay, now for the next one, let me hit second bars, number 3. Again, number 3 is when you're trying to find the A value underneath. I know the area there is 0.04. And the difference here is that the tail is not pointing to the left. The tail is pointing to the right. So make sure that right is highlighted. Go down there to enter, or excuse me, to paste. And I get an area of 1.751. Okay, on the next one, if you're looking close, it says that the area is 0.11. It's 0.11 on each side. Okay, again, 0.11 on each side. So when you go to do second bars inverse norm, you're going to go ahead and put 0.11. And then you can decide whether you want to do the tail on the left or the tail to the right. I already have it indicated to the right, so not that big of a deal. And you will get a value there of 1.227. On the other side, right, since it says negative A, you'll get the negative 1.227. All right, so 0.54 is the area that's indicated. When I scroll down here, I'm going to go ahead and pick center. And then I can get down to hit paste, and I should get those two values, right? One is the one to the left, and the other one is the one to the right. There's the answers. Okay, and then sometimes they're not going to give you a picture. Okay, what they're going to give you is just some notation. And I'm noticing right now I have a typo on this. I will fix this before you get yours, so yours won't have the typo. There should not be a 9 there. Okay, so this one, you could draw some little pictures, right? You could draw little pictures. Notice this is a standard curve. So for A, what this is asking is, if we are at this location, 2.18, what is the area underneath? Okay, and for B, again, here's your normal curve, and we want the area that is greater than the 1.9. Okay, for C, again, it's a bad picture, but we want the area in between 0.2 and 1.4. And then for D, the absolute value is going to be less. So here's the sort of the picture for D. this would be negative 1.23, and this would be positive 1.23, and that's the area. Okay, so I'm going to let you guys do those on your calculator, and I'm going to put the answers up. So there's the answers in red next to the problems themselves. Okay, so again, hopefully you were able to get those answers on your calculator. If not, again, hit me up on Zoom. Okay, so now this problem down here where it says, notice this is not standardized, right? This is not a Z, and these numbers are not 0 or 1. Okay, so what you're going to do is use a formula. Here it is. Z is equal to X minus mu over sigma. This is going to be used to standardize it so that you can continue to use your calculator the way you've been doing. So let me show you what this looks like. I'm going to be using this number right here for X. Okay, so Z is going to equal 15 minus, just a reminder, this is the mean, so that's 14 because of this number, over sigma, which here is going to be 4. And if you simplify that, you get 1/4. So you're trying to find when Z is less than 1/4. So that's what you're going to put in your calculator. And then for this one, again, if I try to standardize this, I'm going to have 7 minus 14 over 4. Again, I'm just using this formula, which gives me negative 7/4. And I look back at this symbol, so I'm trying to find where Z is greater than negative 7/4. Okay, so again, in your calculator, try those. I'm going to put the answers up. Okay, so here are the answers to those two. They are in blue, highlighting them so you can see them. Again, double check, make sure you actually do those in your calculator. Okay, so I've scooted it up for this example. Notice that it says, for this problem, that the language test follows a normal distribution, okay, with a mean of 25 and a standard deviation of 3. Here's the notation for that. Okay, so it's a normal distribution. The mean is 25, and the standard deviation is 3. Okay, now you could normalize this. It is possible, and I'm going to show you in the calculator how to do this without normalizing. So for this problem, we're trying to find the probability that X is greater than 30. Okay, so for this example, I wanted to make sure that you know that you don't have to necessarily standardize. There's a reason I covered that, and it's because of the next lesson. I want you to be kind of comfortable standardizing. But it is possible, and I'm only going to do one of these. This is the example about the language test with the normal distribution. So if I do second vars normal CDF, right, and I want the probability to be greater than 30, that means my lower limit is going to be 30. The upper is going to be a very, very large number. But in this case, I'm not going to standardize it. I'm going to actually use the mean that they tell me of 25, and I'm going to use the standard deviation that they tell me, which is 3. And if I paste, I should get the 0.4048. So that's how you can actually use the mean and the standard deviation that they give you without standardizing. I just want you to see it because you will need it for the next lesson. When you do this in your calculator, you will get 0.048. Now keep in mind, that's for 1 week, okay? But there are 35 weeks in the school year, so we're going to multiply this by 35, and we will get approximately 2 tests. For this one, if we want less than 23 minutes, we want the probability that X is less than 23. Your calculator will give you an answer of 0.252, and again, you have to multiply that by 35 weeks, which gives you approximately 9 tests. So between 18 and 25, we want this to be between 18 and 25, which comes out to be approximately 0.49 times the 35 weeks is approximately 17 tests. Okay, and then the last problem down here, the weight of apples follows a normal distribution with a mean of 45 and a standard deviation of 5. Okay, so the question is, and again, sort of a little picture for some of you that are visual. So this is asking, find the value of the limits. So you're finding these numbers down here. We want the central 80%. So we want this shaded area to be 0.8. And again, if you do this in your calculator, you should get a value down here of 38.6, and this value should be 51.4.